I ever wonder how those massive ships, the ones that could practically carry a whole city, how do they survive in the ocean, like for decades?
Yeah, I mean, you picture those huge cargo ships battling huge waves, hurricane force winds. It's got to be tough on them, right?
Exactly. But beyond those storms, beyond those visible challenges, there's this kind of silent, relentless enemy always at work: corrosion.
Corrosion. Ah, so we're talking about rust. Like, what happens to my bike when I leave it out in the rain for too long?
Well, kinda, but on a whole other level. I mean, we're talking about gargantuan steel structures, constantly exposed to some of the harshest conditions on the planet: salt water, sun, the works.
Okay, so when you say a whole other level, what kind of damage are we talking about here?
We're talking billions, with a B, billions of dollars spent every year just on maintenance and repairs to combat the effects of corrosion on these ships.
Wow, okay, that's a lot of money. So it's a big deal then, this whole corrosion thing.
Huge deal, because it's not just about the cost, it's about safety too. If corrosion eats away at a ship's hull or its internal system too much, well, it could be disastrous.
Makes sense. So what's being done about it? How do we fight back against a force of nature like that?
Well, that's what makes this deep dive so fascinating. We're going to explore a project called Kimiko, and it's using cutting-edge technology to tackle this age-old problem:
And when you say cutting edge, you mean?
artificial intelligence.
Whoa,
Yeah.
really? AI is being used to combat corrosion. That's incredible. How does that even work?
That's what we're going to unpack today. Essentially, Kimiko is a platform developed by Navantia and HI Iberia that brings together different AI models, each designed to target a different aspect of the corrosion challenge.
Okay, so it's like a team of AI specialists, each with their own area of expertise.
Exactly. And the first model is all about predicting the enemy, so to speak. It tackles those environmental factors that make corrosion worse.
Environmental factors. Give me some specifics. What are we talking about?
We're talking about everything from the ocean's temperature and salinity to the currents, even the time of year. This AI gobbles up tons of historical data about those factors and uses that to predict the corrosion weather, you could say, that a ship might encounter on a particular route.
Corrosion weather. I like that. Okay, so let's say a shipping company wants to chart a course from, say, Singapore to Rotterdam. This AI could analyze the route, the time of year, all of that, and predict how corrosive the conditions might be.
You got it. It's like a supercharged weather forecast, but specifically for corrosion. And that information is crucial because it then feeds into the next AI model.
So the first AI predicts the risk, and then the second one, what does it do?
The second AI simulates how that risk might actually play out on the ship itself.
Okay, now this is where it gets really interesting. So it's not just predicting the overall corrosive conditions,
Yeah.
but actually simulating how that corrosion might happen in real time.
You got it. So imagine being able to fast forward, like hitting play on a time-lapse video, and actually seeing how corrosion might eat away at a ship's hull or those intricate networks of pipes inside, all based on those specific environmental factors. That's what this model can do.
That's amazing. But how does it do that? How do you simulate something as complex as corrosion?
That's where things get really wild. This is where the third AI model comes in, and it utilizes something called molecular dynamics simulations, and it's pretty high-level stuff, but bear with me.
Yeah, break it down for us.
So basically, imagine being able to zoom in on the material's structure way down to the atomic level and actually see how the individual atoms and molecules behave as corrosion takes hold.
Wow, it's like getting a microscopic view of the battle against corrosion as it's happening. That is wild. So we've got AI predicting the environmental risks, simulating the actual corrosion attack. What's next?
Well, here's the thing. Kimiko doesn't stop at understanding the problem.
Mhm.
The real magic happens when it uses all of this knowledge to actually design the solutions.
Solutions, like what?
Like new and improved materials designed to resist corrosion. This is where the final two AI models come in.
Okay, so the AI is not just analyzing and predicting, it's actually designing. That's incredible.
It's like having an AI-powered materials scientist on your team, constantly experimenting, searching for the best defense. One AI focuses on developing new types of steel alloys for the ships themselves: stronger, tougher, more resistant to the corrosive onslaught.
That makes sense. You're making the ships themselves more resilient.
Yeah.
And what about the other AI model? What's its specialty?
That one's all about the protective coatings. Those specialized paints and barriers they apply to ships to shield them from the elements.
Right, right. So this AI is tasked with finding new formulas, new ways of creating those coatings that are even more effective.
Precisely. So it's this two-pronged approach: make the materials themselves tougher, and then give them an even better suit of armor with these advanced coatings.
That's brilliant. This Kimiko project sounds like it has the potential to revolutionize shipbuilding, maybe even other industries too. But how do we know it works?
Great question. And the answer is real-world testing. All of these AI-designed materials, they don't just stay theoretical. The most promising candidates get put through the Ringer lab tests, field trials, you name it.
So they're taking these AI design materials from the computer, creating them in the lab, and then actually putting them on real ships to see how they hold up.
Exactly. It's about taking all that incredible AI insight and making sure it translates into tangible improvements in the real world.
And that's what I find so fascinating about this whole thing. It's this incredible intersection of cutting-edge technology and this age-old problem of corrosion that's been plaguing seafarers for centuries. If we can use AI to win this battle, what else are we capable of achieving? It's mind-boggling.
It really is amazing to think about. We started by asking how ships survive in the ocean, and now we're talking about AI designing the ships of the future. Who knows what other challenges we can solve if we set our minds to it?